we have knowledge of atomic structure, we have knowledge of certain parts of physics, that is wavelength, radiation, etc. We have knowledge of now periodic table, that means the elements in periodic table, certain characteristic of that element. Then we have knowledge of chemical bonding also, not 100% but to certain extent. Then we have knowledge of carbon or chemistry of carbon compound. So we are trying to get knowledge about universe from different aspect, yet we have not started out biology. But before that we should start out another important topic about this knowledge of universe, that is nuclear chemistry or nuclear physics. Say a certain part they are common in both the topic. In certain way it is differ, but certain topics are same. Now you are aware that there is atom, inside atom there is nucleus, and now we are focusing on this nuclear aspect in order to get deeper knowledge about universe, because after discussing this chapter entirely you will able to know many things about this universe more clearly. Again keep in mind, whatever we are discussing here, that is just about 4% knowledge of universe what we have today. So in that we means scientists have, I don't have that knowledge, but out of that we are going to discuss. So try to focus, try to concentrate. Number one, that we are talking about atomic structure. At that time we discuss that atom is having very tiny nucleus at center, and electrons are revolving around it in different orbits. Now you are aware that orbit shape is not same. Sometime orbit shape is spherical, don't say circular, though I am showing in circular manner because this is plain board and I am not able to explain three-dimensional view because we are using minimum animation, and therefore you have to consider that is spherical. Sphere is three-dimensional figure, whereas circle is two-dimensional figure. That means I can have two dimensions in order to explain circle, that is x-axis and y-axis, both axes sufficient, but in order to explain figure like sphere I should go for z-axis also. So it is called as three-dimensional figure graphically. Now we are focusing about nuclear chemistry. Now atom we are considering spherical in shape. No doubt that various orbitals like d orbitals are there, p orbitals are there, they are having dumbbell shape or somewhat similar to dumbbell shape, that is English 8 shape. But still we are considering atom as spherical in shape, and nucleus is at center of the atom. Let me clear this point again. This is say spherical atom, this is atomic diameter, whereas suppose this is nucleus, or I should show this in red color, it appears only black because say black ink is there along with that. So this is nucleus, then I should show this way here, this is nuclear diameter. Approximately, suppose this diameter is 1, okay, so I am showing this diameter as 1, then this diameter is 10 raised to 5. That means this diameter is these many time to that of atom. Approximately I am telling you. Right now we can consider this way. Now you are aware that this diameter, what 10 raised to 5 I have written, this diameter is actually we are considering in range of 1 angstrom, that is equal to 10 raised to minus 10 meter. In unit chapter, try to recollect, we discussed this. So whatever that, this is 10 raised to 5 times smaller than that. So this diameter should be 10 raised to minus 5 angstrom. Getting idea now? So if this is 1 angstrom, this is 10 raised to minus 5 angstrom, or simply it is 10 raised to minus 15 meter. Now this unit is called as Fermi, but F is small. Fermi is name of Italian scientist initially and then American, who discuss various facts about nucleus of atom. In honor of that, unit is given as nuclear diameter in terms of Fermi. So that is 10 raised to minus 15 meter, or that is equal to 10 raised to minus 5 angstrom. But no doubt his name is there, that is proper name, so it should be there in capital letter. But as we are aware that below metric level, whatever the units are there, we are writing it with small letter. Therefore, I have written here in small letter. So 1 Fermi, that is equal to 10 raised to minus 15 meter or 10 raised to minus 5 angstrom. Let me clarify this concept to greater extent. Imagine atom is circular in size. Imagine whatever ground is there, playground is there. Suppose that playground is of diameter 1 kilometer. Many playgrounds are having diameter in this range. That's why I am taking this example. So imagine playground is having diameter as 1 kilometer. Then this is at nucleus, suppose. Then what is atomic size? That should have diameter 1 lakh kilometer. You are aware that Earth is having diameter in range of 12,800 meters. Kilometers, sorry. So Earth is having diameter at 12,800 kilometers. Whereas what we are saying, if nucleus is at 1 kilometer range, then diameter of atom should be 1 lakh kilometer. That means almost 7 times greater than size of Earth. And that's why we are saying there is tremendous hollow or say space inside the atom till we reach at nucleus. So all these concepts you have to visualize. By examples I am telling you, but we have to visualize these concepts. So first part is clear, that what is the relation between atomic size and nuclear size. Nucleus is almost 1 lakh times shorter than atomic diameter, and that's why we are saying nucleus is extremely tiny. It is considered as almost point object, like that. The first part is over. Now just we get introduction about what is nuclear size and atomic size, and now we are starting with next part. In such a tiny nucleus, protons are remaining together. You are aware protons are having positive charge. Positive charge should repel another positive charge. But here all protons, let us check out for hydrogen atom, there is only one proton. As you are aware that atomic number of hydrogen, we are writing this way, atomic number of hydrogen is 1 and mass number is also 1. So there is only one proton in nucleus of hydrogen. If I am talking of calcium, it is having 20 protons, mass number is 40, that means 20 neutrons. So inside the nucleus of calcium atom, 40 particles. Now these particles inside nucleus, we are calling them as nucleon. So there are 40 nucleon. Out of that 20 protons are there and 20 neutrons are there. They are packed together in such a tiny place, that is nucleus. In case of uranium, you are aware various isotopes of uranium are there. I am talking of uranium 92, that is isotope is 238. In this uranium 92-238, 92 protons are remaining together inside nucleus of uranium, whereas remaining, that is 148, is number of not 148, it is 146 number of protons are neutrons are there. So 146 neutrons and 92 protons are staying together in the nucleus of uranium. The most important thing is that atomic number increases, but nuclear size is not increases to that extent. I'm not saying it is never increases, but it is not increases to that extent. Now question is that how 92 protons in the nucleus of uranium remain together without repelling each other. Getting idea? How 20 protons inside calcium remaining together without repelling each other. Let me give another concept. You are aware of periodic table. You are aware that in third row element we move from left to right here. Try to recollect. The first element in third row is sodium, then it is magnesium, then aluminium, then silicon, then phosphorus, then sulfur, chlorine and argon. So 4 and 4, 8 elements are there. Atomic number 11, last atomic number here is 18. What is happening about these atoms? As we move from left to right, atomic size decreases. Why decreases? Because nuclear charge increases. Here 11 protons are pulling out 11 electrons. Here 12 protons are pulling out 12 electrons. 13 protons pulling out 13 electrons. No new shells are added. Say configuration is always third shell is last shell, because this is third row element. So third shell is last shell, and therefore we are not getting any different thing, that there is no reason that atomic size should increase. But because of nuclear charge increases, attractive force increases and atomic orbitals start shrinking out. But chlorine is showing minimum or least atomic size from sodium to chlorine. In case of argon, it is expected that atomic size of argon should be less than size of chlorine. But practically, argon is having greater atomic size than chlorine. Why it is so? Answer is very simple, that every time we are adding out new electron and orbital size shrink out. We are adding out one more electron, orbital size shrink out. Like that, when 8th electron is added, orbital size shrink to that extent that electrons start repelling each other, and ultimately orbital, instead of contracting, get expanded, and that's why we are having bigger atomic size for argon than chlorine. If this explanation is valid, then obviously next question is there, that if 8 electrons are not able to stay in an orbit where diameter is of 10 raised to 5 times greater than nucleus, whereas in case of nucleus, why 20 protons, or in case of argon 18 protons are staying together in this so small tiny space without repelling each other. Getting idea? So this is the basics of our nuclear part of chemistry or physics, that why protons are not repelling protons in the nucleus. That means atom should be unstable as its nucleus is unstable. But now we are finding out answer. That means first we discussed that why nucleus should be unstable. Now this is the reason why nucleus should be unstable. And now we have to account why it is stable, because physics or whatever the science is there that goes on the topic what is, what it should be, but what is, and we have to find out the answer. Say for example, here the atomic size, nuclear size should increase, but it is not increasing. Proton-proton repulsive force should dominant, but it is not. Whereas atoms are surviving from the beginning of this universe, at least when they form, from that till date they survived. And then we have to find out answer. According to the concept, it should be destroyed, but it is not destroyed. So it should be destroyed, that is called as instability, but they are not destroyed, they are staying together. That means there is some sort of stability, and we have to give account for this stability. So our nuclear chemistry or nuclear physics topic first goes with this topic about nuclear stability. Then we are going again to nuclear instability, but later on. So first we have to find out answers. Please keep in mind, we are not going in detail. this chapter we are going to discuss only superficial level, not at very depth. Alright, but whatever depth is there, you have to enter in that depth. So we are now accounting about nuclear stability. Now nucleus is stable and we have to find out answer of its stability. So we are finding out first thing about fundamental forces. Before this discovery, only two forces in this universe were considered as fundamental forces, namely gravitational force and electrostatic force. In case gravitational force that was, as you are aware, discovered by a great scientist, Sir Isaac Newton, British scientist. The thing is that every mass, whenever there is mass, that is attracting another mass towards each other. You are aware that gravitational force of attraction we can give by this way. This is suppose force of attraction is directly proportional to product of masses. So I should give you, suppose I have to find out the gravitational forces between moon and earth. Then suppose mass of earth is m1 and mass of moon is m2. Then it is product of m1 into m2 upon the distance between them. Now in case of earth, suppose this is earth and this is moon. So this is having mass m1, this is having mass m2. I have to go to center and I have to measure distance between two objects. This distance is r. So force, that gravitational force, is directly proportional to product of their masses, that is m1 into m2 upon square of distance between them. So r square. Now this is gravitational force. You are aware that I can't use this sign. So I have to replace that sign. And then I am replacing out that sign, that is equal to sign, and I have to put some constant. So here some constant is put, that is called as universal gravitational constant. That is given by capital G. m1 m2 upon r square. Can you find out value of G? Answer is yes. By knowing m1, by knowing m2, by knowing r square, and by knowing value of force, at that time you can just substitute all value, you will get value of G. This value is constant throughout the universe. I am revising again. That's why it is called as universal gravitational constant. Many students are confusing this G with this G. This G we are calling as gravitational acceleration. On value, we are taking 9.8 meter per second square. Try to recollect, this is gravitational acceleration, and usually on surface of earth we are considering this value is 9.8 meter per second square, but its value changes according to, for example, if you are there on North Pole, its value is 9.83 meter per second square. If you are there on equator, its value is 9.78 meter per second square. So like that its value changes, but this is universal gravitational constant, and so its value never changes. Suppose you are at center of earth, then value of G is 0. Keep in mind, at center of earth, value of this G, that is gravitational acceleration, is 0, but value of this G is whatever that value, that is constant value. Now value of this G, you have to by heart that value, that is 6.67 into 10 raised to minus 11. What is unit of this? You can check out this way, that G equal to, I am taking this F into R square upon M1 M2. What is unit of force? Newton. What is unit of R? That is meter. So it is meter square. So Newton meter square upon M1, that is kg, into kg. So it should be I am removing this, it should be kg square. So I can write down this unit as Newton meter square per kg square, or Newton meter square kg raised to minus 2. Getting idea? So this way we can calculate unit. Suppose unit is there, constant is there, what is the value of its unit, that we can calculate this way. Now here we are getting value of this capital G as on experimental basis it is determined, that is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now you are aware the entire formula, the force, that is gravitational force, that is equal to G, that is capital G, m1 m2 upon r square, and we determine value of G. Now if value of G is there with you, then by knowing either of these, say there are total 4 variables, 1, 2, 3 and 4. If 3 variables are known, we can calculate 4th variable, that is gravitational force. Suppose mass of m1 m2 is known and distance is known, then we can calculate force. Now gravitational force is having very less magnitude but more range. What is the force with which Earth is revolving around Sun? That is gravitational force. What is the force with which Pluto, no doubt we are considering it is as dwarf planet, but still it is revolving around Sun, that is gravitational force. Distance between Earth and Sun is called as 1 astronomical unit. The average distance between Sun and Earth is considered as 15 crore kilometers, that is equal to 1 astronomical unit. Now distance between Pluto and Earth or Pluto and Sun is still great, and still Pluto is revolving around Sun. Sun is revolving around center of galaxy, because the entire galaxy is moving. We are calling that as cosmic year. To that Sun can complete out one rotation around center of galaxy. Now here we are getting this type of concept, that gravitational forces are having very, very long range. Magnitude wise it is less than electrostatic force. Let us check out. Magnetic force is also part of electrostatic force only. So I am considering that is electromagnetic force. Let us check out certain concepts. I am holding, say, suppose this is, I am saying pen, but it is not pen. Just imagine it is iron nail. I am placing this iron nail over here and just dropping out, releasing out my hand. It will drop down easily. What is the reason behind that? You can give immediate answer. As you are grown up, you can say it is because of gravitational force. Keep in mind, why pen is attracted towards Earth? Because it is gravitational force. I should not say pen is steady only. Earth is coming towards pen, because say force is depending upon m1, that is mass of Earth into mass of pen upon r square. So motion should be there, but may be possible this is also right, that pen is also pulling out Earth towards itself. But here m1 is very, very, very greater than m2, and therefore m2, that is pen, is attracted towards Earth because of gravitational force. Can you imagine, after dropping this pen or say nail, iron nail, after dropping this iron nail, it is started moving up. Is it possible? Yes. I have to hold here another strong magnet. Suppose I am keeping here magnet and now I am dropping out pen or releasing out hand, then this nail, if it is iron nail, it will start moving towards magnet and not towards Earth. Why? Electrostatic force or electromagnetic force is greater than the value of what the magnitude is greater than that value of gravitational force, and therefore it is attracted towards that magnet. Now imagine, on this is some 10-story building where I am taking out this lecture. Suppose magnet is placed at 10th floor and iron nail is released from here. Can it get attracted towards that magnet? Answer is no, because magnetic force is having less range but greater the magnitude. So range is important, but suppose I am going to 10th story of this building and dropping out pen, then it will drop again down. Why? Because magnitude of gravitational force is less, but range of gravitational force is very, very high. So this is about first two forces we discussed, that is electrostatic force and gravitational force. For electrostatic force, we have to give formula. Let us check out that formula. In case of electrostatic force of attraction, similar formula is there like gravitational force. Suppose these two charges are there. They are placed apart by distance r. And this is vacuum. They are placed in vacuum. No other forces are applicable on that. Only electrostatic force is applicable. Then the value of this force that is given, say this charge instead of m1, for charge we are using q. So this is q1, this charge is q2. Distance between them is r. Then I can give this force is directly proportional to q1 q2 upon r square. This is similar formula as we discussed earlier. The gravitational force is directly proportional to product of masses upon square of distance between them. So here the force is directly proportional to product of charges upon distance between them, square of distance between them. But again we are not able to calculate, so we have to make here some constant and equality sign. So force equal to some constant into q1 into q2 upon r square. So this is the formula you should remember early. But then there is question, what is this c? The constant we are saying it is 1 by 4 pi, and this letter we are reading as epsilon and 0. 0 stands for vacuum. Suppose I am writing here epsilon air, the epsilon a, then this is called as air. Now for vacuum, vacuum means here I am writing nothing is there, therefore I am writing this is vacuum. The epsilon naught is important part. So 4 is constant, you are aware pi is also constant. So we have to give value of epsilon naught. Now in order to substitute this, first I have to check out what is the epsilon naught. So first I have to substitute here, it is 1 by 4 pi epsilon naught q1 q2 upon r square. So I must take epsilon naught here. So epsilon naught equal to 1 by 4 pi q1 q2 upon f and r square. Getting this f I am taking here. So epsilon naught is going here. So what is the expected unit? The value, first I should go and then unit. Charge is having unit as coulomb. So this is coulomb into coulomb. Force is having unit as Newton, and distance is meter. So meter into meter, meter square. So it is c square upon n m square. Now this value for epsilon naught I am giving you value, that is 8.85 into 10 raised to minus 12, and unit c into c, that is c square. N I should take at numerator, then it should be n raised to minus 1, and m also I have to take at numerator, so it should be m raised to minus 2. Or I can write this way, 8.85 into 10 raised to minus 12. Say you have to by heart this value only, then c square upon Newton meter square. So this way we can say this is electrostatic force of attraction. This is given attraction or repulsion, because if both charges are like, then they will obviously repel each other. Like means same charges, so positive positive repulsion, negative negative repulsion, whereas positive negative or negative positive, then it is attraction.